So in a given problem, he is asking for a Fourier transform to exist, the location of poles on the S-plane is. So we know that the Fourier transform is nothing but a Laplace transform because if you see the Laplace transform of any signal f of s equal to 0 to infinity e power minus st into f of t into dt, right? So s is actually, it is a combination of real and imaginary terms, sigma plus j omega, but we know that the Fourier transform is only will be representing f of j omega. So that means the Fourier transform is nothing but a Laplace transform on the imaginary axis. So that means this is 0. If this is 0, then s equal to j omega, then this will become f of j omega equal to 0 to infinity e power minus j omega t into f of t into dt. So this is the Fourier transform. So we can get the Fourier transform from Laplace transforms if s equal to j omega, or we can say the Fourier transform is nothing but the Laplace transforms on the imaginary axis. So this is clear. And one more thing is, in order to exist for a Fourier transform, the system should be stable. We know that in order to become the system stable, all the poles of a system should be on the left hand side, because if it is on the right hand side, what will happen? It will be exponentially increasing. If it is a left hand side, then it will be exponentially decreasing until it will come to 0. So that means all the poles should be on the left half of the S-plane in order to get the Fourier transform of a signal. So from the options, if you see here, this is on the left of S-plane, this is fine. So this will not be, because this is for unstable system. So if it is on the imaginary axis, then the system should not be, the system is not stable, because this is a marginally stable. So this is also not, so this is also wrong.